in Algebra 2, we have moved on to Chapter 7, and I'm going to do, oh, I do have Chapter 8 here. Okay, so I've got 7 and Chapter 8. So for this, we are dealing with logarithms. So I've got here our little cheat sheet for logarithms, where b is the base, x is the argument. I am underlining that because you need to know what the argument is. And I've got y as the exponent. So what I'm going to do is I'm going to give a couple examples of how we move these around to set them up, converting between each of these forms. So if we look here, it's this format, so it's our second format. So I've got my base, I've got my exponent, and I've got my argument. I'm going to write those down real quick, and then I'm just simply going to put this back into y equals log bx. Okay, so I'm going to plug in my y, which is 2. I'm going to carry down my equals sign. I'm going to bring down my log, and I'm going to put b is 6. And then I've got that my argument is 36. And that's my answer right there. Okay, I'm going to do the same thing over here. My base is 8. My exponent is 4, and my argument is 4096. So I've got y equals log base x. So I'm going to start by plugging in my exponent. Do not forget your equals sign. Then log of my base, and then my argument, 4096. And that is my final answer for switching between those. Okay. So for our next thing, we are going to look at this top part. So it looks like that. So I know that my exponent is going to be my 2. My base is 8, and that leaves my argument to be 64. So when I plug this back in, it's going to go b to the y equals x. So 8 squared equals 64. And you can see how that actually is a true statement. So here I've got, let me see, my exponent is 4, my base is 2, and my argument is 16. So if I put that in right, it's going to be b to the y equals x, 2 to the 4th equals 16. And if we do 2 times 2 is 4, times 2 is 8, times 2 is 16. We can see that 2 to the 4th power actually is 16. That's all from 7.3. You have to be able to go between these two forms. So I will pause right here for a second. Make sure you know that this is the argument and where it's located in both of these problems, okay? Okay, we're going to move on to 7.4. So 7.4 was the expanding and the condensing of logarithms. So I put the properties up here real quick. When they're multiplied, it's addition, or when it's addition, they're being multiplied. When it's division, they're subtracted, or when it's subtracted, it's division. And if it's to a certain power, you simply move that power out front. So when you're dealing with condensing, you're going to want to start here and work up. When you're dealing with expanding, you're going to want to start here and work down. So condensing goes this way, expanding goes this way. So it kind of looks like extra credit, okay? So I am going to condense this. So I'm going to start from the bottom and work up. So I'm going to start with power. And if you'll notice, I do actually have a couple that follow this little formula here. So all I'm going to do is I'm going to switch it to where I make this an exponent of x. So I'm going to have log x squared. Okay, and then I'm going to put my plus. Ooh, that's going to come in handy in a second here. And then I've got another one that looks exactly like that. So I've got 3 log y. So this is going to end up looking like log y cubed. Okay, I don't have any subtraction signs, so I'm going to look here and I'm going to say I have an addition sign, which means this is multiplication, so I'm going to condense it into looking like this. So I'm going to have log x squared y cubed. And that is my answer. As I said a couple days ago, this is all multiple choice. So as long as you know the basics of these right here, as long as you know those, and I'm going to erase my underlines so it's a little less confusing. As long as you know these basics right here, it's going to make it to where any of these problems should kind of stand out to you. Just pay attention, be able to say, oh, this is power and product. So you're looking for something that has a power and a product. So it's a product of powers at that point. Okay, let's flip this over. And also in chapter 7.4, I believe it was, yes, 7.4, we had change of base. So change of base simply says if you have something that's written like log of a base to the argument, or log of the base with a certain argument, you can actually rewrite it as log of the argument divided by the log of the base, and it makes it to where it puts it in base 10 for you, so you don't have to worry about if it's like this example, log sub 3, so log base 3 of 16. We don't really know how to find that without having a really complicated, I mean, we could write it as 3 to the what power equals 16, and then we would have to go through all this problems for it. However, we can simply solve this by setting it up as the logarithm of the argument, which is 16, divided by the log of the base, which is 3. All it's going to ask you to do is how to rewrite it in change of base. If you wanted to solve this, you would put this in the calculator to solve. So calc to solve, unless you want to memorize all those log charts, but you don't need to solve it for your exam. You just simply need to know how to rewrite it like this. Okay? And then our final thing in chapter 7 is just you need to know that continually compounded interest is this formula right here. It's going to give you the options. So you've got simple interest is the other one you may get confused with. So simple interest is simply I equals PRT. You are not looking for that one. You are looking for the one that uses Euler's number here. So this is Euler's number. This is the one that you will find in your calculator as the second function of ln. You don't need to solve anything for this. You just simply need to look for the word continually compounded, and you're going to say, oh, that's this one right here. So make sure you recognize that. And then finally for this section, we have 8.5. The only thing from chapter 8 that they want you to know is how to convert from degrees to radians and radians to degrees. So I have our handy dandy little formulas here. What you want will be on top. So if you want it to be in radians, you're going to have a pi on the top. If you want it to be in degrees, you're going to have 180 on top. So I'm going 180 degrees to radians. So I'm going to do, oh, this is 108 because I can read. 108 times pi over 180. So this is going to be 108 pi divided by 180. Let me see, they are both divisible by 9, so this is going to give me 12 pi over 20. They are both divisible by 2, so this is going to give me 6 pi over 10. Both divisible by 2 again, 3 pi over 5. Now, had I looked at that, I would have actually been able to say, oh, 12 and 20 are both divided by 4, and I would have saved myself a step. But I didn't do that. That's okay. That's my answer. So here, if I look, I'm going to degrees, which means my degrees are going to be on the top. So I'm going to have 7 pi over 12 times 180 over pi. If you look, I've got a pi here and a pi here that I can cancel out. So I've got, let me see, 7 times 180 divided by 12. I'm going to simplify this down, and I'm going to say, I think that 180, I know it's divisible by 6, and I know 12 is also divisible by 6. So I'm going to do 7 times 30 divided by 2. So I see that 30 is divisible by 2, so I've actually got 7 times 15, because that's going to cancel out. That's how I get the 15. And then I can say that 7 times 15, 7 times 5 is 35, 7 times 1, 7. So this is actually going to be 105 degrees, okay? So there we have it. That's how you go back and forth between these two. I will see you guys on Monday with our review of either just chapter 9 or chapter 9 and chapter 10. I believe it's just chapter 9 because we're starting to get into the stuff that's more Algebra 2 based, more of what you absolutely need to know versus some of the stuff that you would have come in with previous knowledge for. So I will see you guys on Monday, and I hope you have a wonderful weekend. Contact me if you have any questions.